All right, the longest recorded pass in NFL game traveled 75 yards in the air from the quarterback. At what speed, 45-degree angle, did the ball leave the quarterback's hands? First thing I'm going to do is I'm going to convert 75 yards into meters. And when you do that, you get 68.6 meters, because it's going to make it a lot easier if we can work in meters, okay? So if you know how to do that, figure it out. So this is a little tricky because you're going to be shooting at a 45-degree angle or throwing at a 45-degree angle. One thing nice about the 45-degree angle is the sine and the cosine of 45 is the same. So let's identify what we know in our problem. We know that x1 equals 0, right? Because you've got this arc here. He's throwing the ball, and if this is our xy plane, this is x equals 0 and y equals 0, and we've got a total high y, and we've got x2 here, right? Y's would be equal to 0. So x1 equals 0, x2 we don't know. Actually, no, we do that. That's going to be 68.6 meters, all right? Vx, let's save that for a second, okay? And we also know a is 0 because in the x direction there's no acceleration in this problem, and t we don't know. Okay, for y, we know y1 equals 0, y2 equals 0, vy, let's save that for a second, a is negative 9.8, and t we don't know. Now let's talk about the y and the x, vy and vx. So what you're going to do is, we don't know what the speed is. This is like the question we're trying to find. What is this value, or what is the v right here? But what this is going to be is it's going to be vx is going to be v that we're solving for times the cosine of 45, because it's opposite over hypotenuse, and the hypotenuse is what we're solving for. So it's going to be vx is v cosine 45. Now it turns out the cosine of 45 and the sine of 45 is 0.76. So I can say this is 0.76 v, and this is 0.76 v. They're actually the same number because 45-degree angle, the sine and the cosine are the same. Does that make sense? So what I can do now is I want to solve for the time. But I've got this variable, and I can put the v in each. So watch how I do this. I'm going to say for the y, so using the y equation, 0 equals 0, right? This is y2 equals y1 plus vyt plus 1/2 at squared. So I can say plus 0.76 v times t, and I got two variables, I know, don't panic, minus 4.9 t squared. Boom, I've got that equation. All right, now I've got two variables, so I can't solve this problem. Okay, on the x side, all right, on the x side I can say x2 equals x1 plus vxt plus 1/2 at squared. Remember, there's no acceleration, so this drops off. We know what x2 is. This is 68.6 equals 0 plus v 0.76, same thing, 0.76 vt. All right, so we've got this equation, and then we have this equation. So we have two equations that have the same two variables, two equations. If you then figure this out mathematically, you can then solve for each. So on this case, I solve for v. Watch what I do. If I solve for v, I divide both sides by 0.76 t. 0.76 t. 76 cancels, and the t cancels. And so v is 68.6 over 0.76 t. And then what I did, I'm trying to figure out how I did this, I then plug this in. So if that's what v is, and it's in terms of t, I can say 0 equals 0 plus 0.76 times 68.6 t over 0.76, no, 68.6 by itself, pardon, 76, that's the t, times t, minus 4.9 t squared. So algebraically, the 76's cancel, don't they? So now my equation simplified equals 0 equals 68.6 t minus 4.9 t squared. Now we have one variable, one unknown. To find the time, you're going to have to plug this into the quadratic formula and use a quadratic formula solver, and I got t equal to 3.75 seconds. Yeah, that's the question. That's t. We haven't solved the question. What speed does E travel at? But once you know t, you can solve v, because we solved v right here. Right, v was equal to 68.6 over 0.76 t. So when you plug the t in, the 3.75 into here, you get an initial speed of 34 meters per second. And that would be the velocity.